So for this lesson, we are going to be looking at the characteristics of quadratic functions and how to locate them on their graph. So a quadratic function, if you remember from the last two units we've talked about, it's a polynomial function with a degree of 2, which means your highest exponent is 2. So it should be the only exponent you have. It does create a U-shaped graph called a parabola. So when you do put these on the coordinate plane, as we've talked about before, they do create that U shape. And the parent graph is actually x squared, which has an x and y intercept of 0, 0. So the parent function is more what I'm drawing here in blue. So you have three common forms. The standard form, which is ax squared plus bx plus c. This is what you guys have factored. You have solved it in a variety of ways. And then we have vertex form. So vertex form is going to become very important to you. You have had to solve this already a few times. But you haven't done a ton of work with it yet. You also have what we call factored form. Now, factored form you probably have used a little bit, especially if you're a person who likes to solve by factoring, because the factored form is what you get once we do factor standard form, and then we use it with the zero product property to solve. So your parts of a parabola. Well, you have, first of all, your direction of opening. So your direction of opening is going to be either up or down. So if you're A, so your first term in standard form, or your number in front of your parentheses in vertex form, if that is positive, then your parabola will open upward and make a happy face. So remember, if you're positive, more than likely you're happy. So you should have an upward facing parabola. And then if you are have an A that is less than 0, so it is negative, it's going to be a sad face and open downward. So that vertex is the turning point of that curve. So it's where you change direction. So if you have a parabola that opens up, that vertex is where you go from heading down to heading back up. So it's where you change direction. And then, of course, if you're opening down, it's going to be that highest point, so where you change direction from going up to going back down. So if you open upward, you have a minimum. And if you open downward, you have a maximum. So if we think about that for a second, if you open upward, that vertex is going to be the lowest point possible. So it should be your minimum. And then if you open downward, that vertex should be the maximum. So we usually express these as the y-coordinate of the vertex. So then your axis of symmetry is actually the x-coordinate of the vertex. So it is made, it is that vertical line that divides the parabola into two congruent halves. But we get the number for it off of that x-coordinate. So it just becomes x equals whatever that number was. So actually we'll call that h, because that is what we use to represent our vertex, H and K. So then your y-intercept is the point where the graph crosses the y-axis. So we will be finding that on the graph. And then your x-intercept is the point where the graph crosses the x-axis, or the points where the graph crosses the y-axis. Because you can have 0, 1, or 2 y-intercepts. And as we mentioned before, that minimum or maximum, that is the y value of your vertex. And so that just leaves us with domain, which we've talked about before. That is the x values for our function. Quadratic functions do not have a limit in the domain, so we will express that either algebraically, where you have all real numbers, or as an interval, where you have negative infinity to positive infinity. Now, your range, you need to know your minimum and maximum value to tell you what your range is. So your range algebraically is going to be, if you have a minimum, y is greater than or equal to that minimum. And then if you have a maximum, so you open downward, y is less than or equal to that maximum. And then as an interval, if you have a minimum, then your interval is going to be that minimum value and then infinity. Or if you have a maximum, so you open downward, then you are going to have negative infinity to that maximum value, because it is as high as you can go. And anytime you put a number anywhere in the interval with a quadratic, you should go ahead and put that bracket on there, because you can touch the value. Okay, so now that we've talked about what all these things are, let's go ahead and take a look at these in Desmos. So now we are in Desmos, and I have our notes over to the side. So we are going to go ahead and graph the function. So all we have to do is we have to just put it in as it said. So you can leave off the f of x. But if you type it in, it's not going to be a big deal. So we have x plus 3, need to close those parentheses, and then squared, and see, we already turn into a parabola, and then minus 4. All right, so then if we look at our graph, we see that we are definitely opening up. So I'm going to go ahead and note that on our notes. And then our vertex. So our vertex is that turning point of the curve. So you can always drag around your graph to get to what you need. And then we are going to go ahead and just click on that graph again. And that gray dot will appear at that turning point. And so we can actually export that point if we want, and tell it to label it if we want to keep it. And so our vertex is -3, -4. Now, something that is really nice about the form of this equation is that it is in what we call vertex form. And so vertex form has h and k in it, which actually you just have to flip the sign on h, and it gives you your x coordinate, and then you just bring over your k. So vertex form actually gives us our vertex without us even having to graph. All right, so is this vertex a minimum or a maximum? Well, we are opening up, So this is going to be a minimum. And it's because we open up. So then that minimum or maximum value. Well, I'm going to go ahead and circle minimum because that's what we're actually using. And so that needs to be our y coordinate. So I'm just going to use that -4. And then our axis of symmetry, that needs to be a linear equation. So that is going to be x equals, because it needs to be a vertical line, and we're going to use that -3. And I can actually go ahead and type that in here just so you guys have the ability to see that that vertical line for our axis of symmetry does go straight through that vertex and divide our parabola into 2 equal halves. Now our y-intercept, I can go and drag my graph. I can click on my function, and then here is my y-intercept at 0, 5. So I'm going to go ahead and note that. And then our roots, remember these are our x-intercepts. So again, I'm going to go click on my function. I might have to drag it a little bit, but then I can just click on those and get those points. And I'm going to have them both labeled. There we go. So we have roots at -5, 0 and -1, 0. And so this is a way that you can actually solve your quadratic equation as well, because this is what we would get for our values of x if we went and we set this equation equal to 0 and solved it. Now our domain is going to be -infinity to +infinity. Because we can open forever to the left and right. And I can zoom out and show you that we can continue to go out. So that is pretty obvious there. All right, and then our range. Well, our range is determined by our vertex. So I'm going to zoom back in on that. And so we cannot go lower than that -4 value. So our range as an interval is going to be a bracket, -4, and then an infinity symbol to show that we can go up forever. And so we can see that go up. And then I could keep scrolling, but we'd be here for a while. But these are all of our characteristics of our quadratic function. So let's go ahead and do this one more time. And in this case, I'm actually going to use standard form. So we are going to have -x² minus x plus 6. And as you can tell, this function actually opens down. And that is because of the negative in the very front of the function. So our vertex is that turning point. So if we want to zoom in on it, we can. And so that is going to be -0.5 and 6.25. Now, is this vertex a minimum or a maximum? Well, this is a maximum because we do open down. So since it's a maximum, I'm going to go ahead and take that maximum value, and that is 6.25. And then for my axis of symmetry, that is going to be x equals the y value of my vertex which is negative 0.5. And yes, it does have to be that equation. We can go ahead and graph that again as well, so you can see how it cuts that parabola in half. So then our y-intercept is going to be 0, 6. And then our solutions, that is another word for x-intercept. So we're going to actually just kind of zoom out a little bit to get that x-axis in. I'm going to click on our function again, and we have negative 3, 0 and 2, 0. We can, of course, export both of those points and get them labeled. So we have 2, 0 and negative 3, 0. And then our domain is going to be, let's do algebraic notation this time. So that's going to be all real numbers, because we don't have a limit to the left or right. But then our range, we have a limit on how far up we can go, because our green parabola does not go above that 6.25. So we're going to say y is less than or equal to 6.25. So let's go ahead and look at another function. This one is also in standard form. So we have 2x squared plus 4x minus 6. And so we are going to look first at our direction of opening. So we are opening up this time again. And then our vertex, we're going to look at that point at the very bottom, and that is a -1, -8. And then, is this vertex a minimum or a maximum? Well, since we open up, then we are a minimum. So we have a minimum value here, and that is going to be what our y value is in our function, which is -8. Then that axis of symmetry is going to be the x value of our vertex, so that -1. But it needs to be a function, so x equals -1. And I can go ahead and graph that. You guys don't have to do this, but I just want you guys to see why we have it and what it does to the parabola. So now let's go ahead and find that y-intercept. So we have that gray dot showing up for us on the y-axis. So we just need to click it and get our point. So that is 0, -6. And then we have our roots. So that gives us -3, 0. And 1, 0. And then our domain, we open out and go to the left and right forever. So we'll go ahead and do interval notation again here. That'll be -infinity to +infinity. And then our range, we'll go ahead and do algebraic notation on this one. So remember, our vertex was at -1, -8. So as low as we can go is -8. So we are going to have y is greater than or equal to -8. So let's go ahead and look at that last function. So this one is also in vertex form. We're still going to type it in exactly as it sits. So our function definitely opens down. So that's our direction of opening this time. And then our vertex, that's going to be the highest point since we do open down. And that's going to be -2, 5. So is this vertex a minimum or a maximum? Well, in this case, it is a maximum. And then that maximum value is the y value of the vertex. So that is 5. Then our axis of symmetry is also coming off that vertex. And so that is going to be x equals -2. I'm going to graph it again for you. Do you have to do that? No. I just still want you to see it. So then our y-intercept, we're looking for the gray dot that crosses the y-axis. And so that is going to be 0, 1. And then we have our roots for the equation. So that is going to be some funky decimals. So we're just going to round this to 2 decimal places. So we will have -4.24, 0, and 0.24, 0. So then our domain, I'm going to go ahead and do this one in algebraic notation. So we have a domain that is in all real numbers because we can go forever to the left, forever to the right. And then our range, I don't want to change color on that one, I'm going to go ahead and do that one as an interval. So our range, we can go no higher than 5. So we'll have a parenthesis and then -infinity. And then we are going to go up to 5. So we'll have a bracket because we can touch it. Okay, so that is all for the examples. As you will find on your notes, we do also have instructions for using that TI-84 calculator, but I'm going to make that a separate video that is not required because you are at this point not able to take those calculators home. And also it is not as user-friendly as Desmos, but if you want to know how to do it in the TI-84 calculator, there will be a supplemental video posted so that you can follow through these examples with the instructions and see how to do it.